All right, today we are going to talk about graphing these trigonometric functions. All right, so we have the tangent function. The tangent function says that, the tangent function, your domain is all real except odd multiples of pi over 2, because if you can see, you have these asymptotes here at these alternating pi over 2's. Okay, so that's what it means by it's all reals except odd multiples of 2, because you have those asymptotes on the odd multiples of pi over 2. Your range is all real numbers. It's continuous on its domain. It's increasing on each interval in its domain. It's symmetric with respect to the origin, so it's an odd function. Because if you took one of these waves, and let's say you reflected it down, which would look like this, and then you reflected it over, would look like this. So that's why it's an odd function. It's not bounded above or below. There's no local extrema. There's no horizontal asymptotes. And again, your vertical asymptotes are at your odd multiples of pi over 2. Your end behavior, the limit of tangent as x approaches negative infinity and as approaches to positive infinity, does not exist, because the function values continually oscillate between negative infinity and approach no limit. All right. So here's some interesting things about the tangent function. The tangent function has asymptotes at the zeros of cosine, and it has zeros at the zeros of sine. Okay, so if you look at the sine function, see it in red right here that I just drew over in blue. Give me a second, let me switch to red. Okay, you see the sine function right here? And you see everywhere that the sine has a 0, the tangent has a 0. Okay, and do you see your cosine function here in red? It has, wherever the zeros of cosine are, you have an asymptote. Okay, so your period of tangent is actually pi, whereas sine and cosine is 2 pi. So the period of the related tan function is pi over the absolute value of b, whereas for sine and cosine it was 2 pi over b. Your amplitude and phase shift are not used. They only apply to sinusoids. So your translations, again, if you've got A, that's going to be your vertical stretch or shrink. If it's negative, that's going to be a reflection over x, which is going to change the direction of the waves. B will affect your period. Make sure you factor B out. If you're multiplying or dividing, you get a new period. H causes a horizontal translation, and K causes a vertical translation, like you know. Okay, so it says, describe the transformation required to obtain the graph of the given function from the basic trigonometric graph. So, the negative in the front is going to reflect over x, and the 3 is going to be a vertical stretch. Okay, for the second one down here, the negative is going to reflect over x. The 3 is going to be a vertical stretch. The 1/2 is going to be a horizontal stretch of 2, because remember you have to flip it over. Okay, on this bottom one, the negative is going to reflect over x. That positive 2 on the end is going to be a vertical shift up, and the pi over 2 touching x is going to be, if you look at pi over 2, secant pi divided by 2 is 1.57, so that's bigger than 1, so that's going to make it a horizontal stretch, shrink of 2 over pi. Okay, you'd think it's a stretch because pi over 2 is bigger than 1, but it's actually going to be a shrink, and then you have to flip it over. All right, so you try this one. Hit pause, come back when you're ready. And hopefully you got 4. The negative is going to be a reflect over x. The 1/8 is going to be a horizontal stretch of 8. You flip it over, and the 6 is going to be a vertical shift up. Okay? Hit pause, come back when you're ready, and hopefully you got 2. The 9 is going to be a vertical stretch. The +2 is going to be a vertical shift up. So you got to stretch a 9 and up 2. Alright, so how do we graph these guys? Well, first of all, you got to find your period. Okay, the amplitude isn't going to affect us. The period is going to be pi over b, the absolute value of b, and then find your scale. Well, on our scale for sine and cosine, we divided by 4, but since our period for tangent is only pi, we're going to divide by 2. And then you draw your zeros, those would be the zeros of sine. Draw your asymptotes, those would be the zeros of cosine, and then draw your waves. If a is positive, they're going to rise to the right, like they do in the pictures. If it was negative, they're going to fall to the right, so they would just turn around and go backwards if it's negative. Okay? Alright, so it says graph the function y equals negative tangent of 4x. First of all, we need to find the period. So my period is going to be pi over the absolute value of b, which is 4. So my period is pi over 4. To get my scale, I'm going to take my period, which is pi over 4, and I'm going to divide that by 2. Let me do it over here. And let me use a different color. So we have pi over 4 divided by 2. Keep, change, flip, and that's going to give me pi over 8. So right here is going to be pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Okay, now for tangent, it says draw your zeros. That would be zeros of sine. If I was graphing the sine function with these intervals or whatever, remember sine does this. Sine would go from, go to 0, and then it would go to, we got a negative, so it would go to down amplitude, and then to 0, and then to up amplitude, and then to 0. Anyway, if you just kind of put those plots, then you can go, okay, your zeros of sine are going to be the zeros of your tangent function. Okay, so right here, here, and here, you're going to have your zeros of the tangent functions. So I draw those, and then I'm going to draw my asymptotes. Those are the zeros of the cosine function. Cosine function has a 0 here, because it would start at amplitude and then go to the 0 and then go to down amplitude and then go to 0 and then go to up amplitude and then go to 0. So everywhere I've got those x's on the x-axis, those are going to be your asymptotes. So through the x's on the zeros, I'm going to make asymptotes. Okay, and then it draw your waves. Since this is negative, normally tangent rises to the right, but we're going to fall to the right. And if you continue the pattern, every other mark is going to be an asymptote, and every mark in between there is going to be a 0. Okay, so now your waves are going to have to pass through those zeros. And again, because they're negative, normally tangent rises to the right, but since it's negative, it's going to fall to the right. So we're going to come down like this. Bloop. Stay in between your asymptotes, and you just kind of wave on through your 0. And there would be my tangent function. Okay? Alright. Come on. There we go. Now, the cotangent function, if you notice, the cotangent function falls left to right. Okay, just it's the opposite of tangent. Okay, the cotangent has asymptotes at the zeros of sine and has zeros at the zeros of cosine. So we've kind of got the opposite thing going on. The period's still the same. It's going to be pi over b. Your scale is still the same. Divide by 2. It's just these two are different now, and it's opposite. Your zeros now are going to be zeros of cosine instead of sine, and your asymptotes are going to be the zeros of sine. So if I graph this one, cotangent of 2x, my period is going to be pi over 2, okay, because b is 2. So to get my scale, I'm going to take pi over 2 and divide it by 2. Keep, change, flip, gives me pi over 4. So this mark is going to be pi over 4. This is going to be 2 pi over 4, 3 pi over 4, and 4 pi over 4. Okay? So, yeah. So we're going to draw our zeros. Alright? If I was doing cosine, the zeros would be amplitude, 0, amplitude, 0, amplitude, 0. Okay? So I've got the zeros of cosine in green. Those are going to be the zeros of my cotangent function. Okay? Then I'm going to draw my asymptotes. My asymptotes at the zeros of sine. Zeros of sine would be right here because you would go 0, amplitude, 0, amplitude, 0, amplitude. Okay, I'm not interested in the amplitudes, I'm interested in the zeros. Okay, so everywhere I've got an x, I'm going to draw an asymptote, and everywhere I have a green dot, those are going to be zeros. So, why did I pick red? It's going to be right on top of that one, and you can't see it. Let me do this color. So you got an asymptote here, an asymptote here, an asymptote here. And again, if you continued that, every other line would be an asymptote. And every other line in between that would be another 0. And now all you have to do is draw your waves. We're positive, so we're going to fall to the right, like a cotangent normally does. And there you go. Okay? Alright, so hit pause, pick the right graph, come back when you're ready, and hopefully you got 3. Alright, so my period would be pi over b, and b is 1/2. That would be keep, change, flip, that would be 2 pi. Okay, so to get my scale, I would do 2 pi divided by 2, which would be pi. So my scale is going to be pi, 2 pi, 3 pi, 4 pi. And you continue that on this side as well. We're doing tangent, which means for tangent, we have our zeros at the zeros of sine. So we have a 0, amplitude, 0, amplitude, 0. And every other mark is going to be an asymptote. So these are all asymptotes. Okay, and we are not negative, so we are going to be rising to the right through our zeros. So I'm going to go back to red, and we're going to rise to the right, rise to the right, rise to the right. So I'm looking at a graph that goes through 0, 2 pi, and 4 pi. And if you look at the scale, this is going out to 6 pi, so this would be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And this one is waving through 0, 2 pi, 4 pi, just like my graph, so it's got to be that one. Okay, it would be this one if it was a negative tangent function. Alright, so pick this one out, hit pause, come back when you're ready, and hopefully you got 2. Alright, so for this one, for cotangent, alright, my period is going to be pi over 1 in this case, so my period is pi. So if I get my scale, I take period and divide it by 2, so my scale is going to be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, let's see, and we're doing cotangent, so for cotangent, we have our zeros at the zeros of cosine, which would be here, and here, and the next one over, so on and so forth. Okay, so then the other lines are my asymptotes. Alright, and we are going to wave. Normally cotangent falls to the right, but because of the negative, that's going to reflect it, so we're going to have to rise to the right. Bloop, bloop. So I'm looking for a graph that goes through pi over 2 and 3 pi over 2. Alright, a negative pi over 2. Yeah. And that would be this one. Okay. This would be a positive cotangent function. This one would be, but it would have to be a horizontal stretch. See how wide the thing is? And I don't have a horizontal stretch. Plus, it's not going through the right thing. This is actually a secant or a cosecant function, which we'll get to in a minute. Oh, right now. Alright, your secant function. Your secant function is just as easy to graph because everything's related to sine and cosine, okay? So secant obviously is reciprocal of the cosine function, and what that means is, if you look at the red graph, there's your cosine function. And notice, all you do is at the zeros of cosine, you put your asymptotes, and at the amplitudes of cosine, you draw these secant curves. They look an awful lot like parabolas to me, but we'll call them secant curves, okay? And you just draw them in between your asymptotes at the asymptotes of your related cosine function, okay? Alright, so your period, again, for secant and cosecant is 2 pi over b, because remember, these are reciprocals to sine and cosine have periods of 2 pi. So the period's 2 pi over b. You find your scale the same way we did to sine and cosine, divided by 4. Draw your asymptotes. Again, your asymptotes are going to be at the zeros of your cosine function. And then draw your secant curves. The minimum of each secant curve, see, the minimum is at the amplitude of its related cosine. Or we should say maximum, I guess, because they're down here too. Alright. So, graph the function y equals secant 6x. So first of all, we're going to find the period, which would be 2 pi over 6, which reduces down to pi over 3. I'm going to get my scale. I'm going to take my period and divide it by 4. Keep, change, flip, and I get pi over 12. So this mark is going to be pi over 12, 2 pi over 12, 3 pi over 12, and yes, I could reduce them, but I'm not going to. 4 pi over 12. The related cosine function for this would be cosine 6x. And if you're doing cosine, the amplitude would be 1. So cosine, you would start at the amplitude, which would be here, and then you would go to 0, and then you would go to down amplitude, then you would go to 0, and then you would go to up amplitude. And our asymptotes are at the zeros of the related cosine function. So my asymptotes, there's my zeros of the cosine, my asymptotes go through the zeros. Every other line. You can extend it on this side, just continue the pattern. Okay, and then at your amplitudes, I'm going to keep going this way. This would be 0, amplitude, 0, amplitude, 0. At your amplitudes, then you draw your secant curves. And your secant curves look like little parabolas at the vertex of the amplitudes. So you have here, you have here, you have here, you have, where am I at? Here, and you have here. And that would be my secant function. And if you drew in your cosine function, there's your related cosine function in the middle. Okay? Pretty cool? Alright, the cosecant function is reciprocal to the sine function. So again, in red, if you look at your sine function, where sine has its zeros, cosecant is going to have its asymptotes. And where sine has its amplitudes, you're going to get your cosecant curves at the amplitude. So it's just the same as secant. It's just that we're shifting by pi over 2. Okay? Alright, so this one says graph the function negative cosecant of x over 2. So I'm going to find my period, which is going to be 2 pi over b, which is 1/2. So if I simplify that, keep, change, flip, I get 4 pi. To find my scale, I'm going to divide 4 pi by 4 and I get pi. So this is pi, 2 pi, 3 pi, 4 pi. Okay, cosecant is related to sine. So if I did the related sine function, which would be y equals negative sine x over 2, that would be the related sine function. This one, normally, sine starts at 0 and then goes to its amplitude. Normally you go to up amplitude, but this time I'm going to have to go down first, and the amplitude's 1, so I'd go down to 1, then my 0, then my up amplitude, then my 0, and I could keep continuing this. Okay, that would be my related sine function. So to do cosecant, we are going to draw our asymptotes, which are at the zeros of the sine function. So I've got an asymptote here, an asymptote here, an asymptote here, an asymptote here, an asymptote here. Okay, and then we're going to draw our cosecant curves, which are the parabolas at each of the asymptotes. So you'd have one here, and 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 it would keep going forever and ever and ever. And again, if you looked at the related sine function, which would do this, you can see the relationship between the cosecant and its related sine function. Alright, so pick out the right secant graph, hit pause, come back when you're ready, and hopefully you got one. Alright, secant is related to cosine, so the related cosine function would be cosine of x over 3. My period is going to be 2 pi over b. Simplify, keep, change, flip, I get 6 pi. To get my scale, I'm going to take 6 pi and divide it by 4, which gives me 3 pi over 2. Okay, so now if I count by 3 pi's over 2's, I have 3 pi over 2, 6 pi over 2, 9 pi over 2, 12 pi over 2. Okay, notice that this would be 6 pi. Alright, so now we're doing cosine. So cosine would start at its up amplitude, because we're not changing, there's no negative, we're not reflecting. So amplitude 0, amplitude 0, amplitude. And I could continue it this way. 0, amplitude, 0, amplitude. Okay, and for secant, you have asymptotes at the zeros of your cosine. So asymptote, 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 asymptote. And you have your secant curves at your asymptotes. Here, 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 and here. Okay, so to find the graph that matches that, well, for one thing, this is a cotangent function. This is a tangent function. And you notice that secants, unless you do a phase shift, secants, because cosine starts at the asymptote, the first parabola will have its dip at the first amplitude, not asymptote, amplitude, on the y-axis, and that's the only one that does, so it's got to be that one. Yeah? Plus, you can tell you have a curve at 6 pi, and this one doesn't. Well, it does, but it's below. Okay. Oh, this one's actually just that one flipped upside down, so if it was negative, it would have been 4. Just saw that. Alright, pick out the negative cosecant of x plus 4. Hit pause. Come back when you're ready. And hopefully you got 3. Okay, so my period would be pi over 1/4. Keep, change, flip, I get 4 pi. So my scale is going to be 4 pi divided by 4, which is pi. So my scale is going to be pi, 2 pi, 3 pi, 4 pi. Okay. This is cosecant, which is reciprocal to sine. So if I was pretending to graph sine, I would do 0. Because of the negative, I would go to down amplitude first, 0, up amplitude, 0. Okay, for this, your asymptotes are at the zeros of sine. So I've got an asymptote, an asymptote, an asymptote, and then we do our curves. Parabola here, parabola here. Okay, so I'm looking for a parabola at, wait a second here. Yeah, this one would be up here, so you have a parabola up here. Yeah, at 1. That's a cotangent, that's a tangent, so it's between these two. So let's see, I'm looking for, how are they counting? This is pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Pi over 1/4. Oh, silly goose. 2 pi over 1/4. I'm thinking the wrong period. My bad. Gotta love your teacher. At least I can admit when I make a mistake. I'm sorry. Period of cosecant would be 2 pi over 1/4. So keep, change, flip, you get 8 pi. I apologize. And then if I take 8 pi and cut it in fourths, I get 2 pi. Alright, so now, that's better, 2, 3, 4, 2, 3, 4. This would be 2 pi, 4 pi, 6 pi, 8 pi. So now, let's try this again. My related sign would be 0, negative is going to make me go down first, 0, up, 0, down. So you're going to have your asymptotes at your zeros, and your parabolas at your amplitudes. There we go. So let's see, at 2 pi then, see there's my upside down parabola at 2 pi. You've got asymptotes here and at 4 pi. See how I have asymptotes at 2 pi and 4 pi. Okay, and over here, so it's got to be 3. Alright. The next part is they want you to identify the graph of each function using your understanding of transformations, not your graphing calculator. Well, tan x, guys, 5 tan x, that would be a regular tan x stretched by 5. If you stretch a curve, it's going to make it a lot straighter. So y1 has to be 5 tan x. Whereas this one, the 0.5 multiplying by it, that's going to be a shrink. So if you squish a curve that looks like this, it's going to widen it way out. So y2 has to be the 0.5 tan x. Pretty simple. Okay, cosecant x would be normal parabolas, kind of like in our picture. Cosecant 2x, that's going to be a horizontal. Oh, silly goose, Tamsin. This is going to be a horizontal shrink of 1/2. And this is going to be a vertical stretch. Oh. So if you did cosecant and you have these things, right down here, okay. If you're going to horizontally shrink them, they're going to get thinner. They're going to get much thinner, and they're going to get taller when you stretch them by 3. So the thinner and stretchier ones have to be this one. So y1 has to be 3 cosecant 2x, and y2 actually has to be cosecant x. Alright, so you figure out which graph goes with which equation. Hit pause, come back when you're ready, and you should get 2. Alright, graph 1. We're looking at tangent to be shifted to the right pi over 2 units, and it's got to be going in the opposite direction. So normally tangents do this. Because of the negative, I know it's going to be falling. So I'm looking at this one, or this one. Okay, well if I shifted to the left, normally tangents start at 0. Okay, we're going negative, so this would be normally where it would be. But I have to shift to the right pi over 2 units, which would be about right there. This one, or this one, shifted over too far. Okay, so 1's got to be D. 2, that's got to be a regular tangent, so regular tangents rise to the right, so I'm looking for one that looks like this, which is either A or C. And this tangent shifted to the right, or to the left, pi over 2 units. So let's see, what am I looking for? I'm looking for, why did I circle C? It could, yeah, because it could be A or it could be C. Sorry. Okay, this function hasn't shifted at all. Because it's still going through the origin. This one has shifted to the left pi over 2 units. So 2 has to be A. 3, negative cotangent of x minus pi over 2. Well, cotangent would normally fall to the right, but again, because of the negative, these are going to rise to the right. So again, I'm looking between A and C. Well, I already used A, so it's got to be C. Okay, because cotangent would normally be over here first, and it shifted to the right pi over 2. Okay, so that would be C, and then 4, the only one left, is D. But again, a cotangent goes to the left. The only two that go left are this one and this one. I already used D, so it's got to be that. Again, normally cotangent would be over here, and it shifted to the left pi over 2 units, so it's got to be D. Alright, so where are the vertical asymptotes of tan, cotan, secant, and cosecant? Alright, well, you're going to have to go back to your notes and look that up. They're right there on the slides for tan, for cotan, for secant, and for cosecant. Okay, tangent, just look at the slides. It has zeros at the zeros of, I'm not just going to tell you, I want you to go look. Okay, and then do the same thing. If you're finding where your asymptotes are, then every other one is going to be where your zeros are. So do the same thing. Go back and look at the slides. Secant, cosecant, and figure out where their zeros are. The period of tangent and cotangent is pi. The period of secant and cosecant is just like sine and cosine, which is 2 pi. And then for 5, how do you graph those? Again, I'm not going to write it all out for you. Briefly describe tan, cotan, secant, and cosecant. I'll give you a little hint. Okay, for tangent, you find your period, right? Get your scale, mark the scale, and then use this information to tell how to plot your asymptotes, plot your zeros, and draw your graph. Okay? And we are at homework, so we are done. Happy homeworking, and I will see you next